A brief history of atomic theory. Nuclear hypothesis is a logical depiction of the nature of atoms and matter that consolidates components of material science, and math. As per present-day hypothesis, matter is made of small particles called iotas, which are thus made up of subatomic particles. Iotas of a given element are indistinguishable in numerous regards and not the same as particles of different components. Particles join in fixed proportions with different molecules to form molecules and compounds. The hypothesis has developed over the long haul, from the way of thinking of atomism to current quantum mechanics. Here's a short history of nuclear hypothesis. The atom and atomism. Nuclear hypothesis began as a philosophical idea in antiquated India and Greece. Iota comes from the antiquated Greek word atomos, which implies unbreakable. As indicated by atomism, matter comprises of discrete particles. Be that as it may, the hypothesis was one of numerous clarifications for issue and did not depend on experimental information. In the 5th century BCE, Democritus suggested that matter comprises of indestructible, inseparable units called particles. The Roman writer Lucretius recorded the thought, so it made due through the Dark Ages for later thought. Dalton's atomic theory. It took until the finish of the 18th century for science to give solid proof of the presence of iotas. In 1789, Antoine Lavoisier figured the law of preservation of mass, which expresses that the mass of the results of a response is equivalent to the mass of the reactants. After 10 years, Joseph Louis Proust proposed the law of distinct extents, which expresses that the majority of components in a compound consistently happen in a similar extent. These hypotheses didn't reference molecules, yet John Dalton built upon them to build up the law of numerous extents, which expresses that the proportions of masses of components in a compound are little entire numbers. Dalton's law of various extents drew from exploratory information. He suggested that every substance component comprises of a solitary kind of molecule that couldn't be obliterated by any compound methods. His oral introduction, 1803, and distribution, 1805, denoted the start of the logical nuclear hypothesis. In 1811, Amedeo Avogadro adjusted an issue with Dalton's hypothesis when he suggested that equivalent volumes of gases at equivalent temperature and pressing factor contain similar number of particles. Avogadro's law made it conceivable to precisely appraise the nuclear masses of components and made an unmistakable differentiation among particles and atoms. Another huge commitment to nuclear hypothesis was made in 1827 by botanist Robert Brown, who saw that dust particles gliding in water appeared to move arbitrarily for no known explanation. In 1905, Albert Einstein proposed that Brownian movement was because of the development of water particles. The model and its approval in 1908 by Jean Perrin upheld nuclear hypothesis and molecule hypothesis. Plum pudding model and Rutherford model. As yet, iotas were accepted to be the littlest units of issue. In 1897, J.J. Thomson found the electron. He accepted molecules could be isolated. Since the electron conveyed a negative charge, he proposed a plum pudding model of the iota, in which electrons were implanted in a mass of positive charge to yield an electrically unbiased particle. Ernest Rutherford, one of Thomson's understudies, negated the plum pudding model in 1909. Rutherford tracked down that the positive charge of a molecule and the majority of its mass were at the middle, or core, of an iota. He depicted a planetary model in which electrons circled a little, positive charged core. Bohr model of the atom. Rutherford was progressing nicely, yet his model couldn't clarify the outflow and assimilation spectra of iotas, nor why the electrons didn't collide with the core. In 1913, Niels Bohr proposed the Bohr model, which expresses that electrons just circle the core at explicit good ways from the core. As indicated by his model, electrons couldn't twisting into the core however could take quantum jumps between energy levels. Quantum atomic theory. Bohr's model clarified the unearthly lines of hydrogen yet didn't stretch out to the conduct of iotas with numerous electrons. A few disclosures extended the comprehension of particles. In 1913, Frederick Soddy portrayed isotopes, which were types of a molecule of one component that contained various quantities of neutrons. Neutrons were found in 1932. Louis de Broglie proposed a wave-like conduct of moving particles, which Erwin Schrödinger portrayed utilizing Schrödinger's condition, 1926. This, thus, prompted Werner Heisenberg's vulnerability rule, 1927, which expresses that it's unrealistic to at the same time know both the position and energy of an electron. Quantum mechanics prompted a nuclear hypothesis in which molecules comprise of more modest particles. The electron can possibly be discovered any place in the iota, yet is found with the best likelihood in a nuclear orbital or energy level. As opposed to the roundabout circles of Rutherford's model, present-day nuclear hypothesis portrays orbitals that might be circular, free weight-formed, and so on. For molecules with a high number of electrons, relativistic impacts become possibly the most important factor, since the particles are moving for a portion of the speed of light. Present-day researchers have discovered more modest particles that make up the protons, neutrons, and electrons, albeit the iota stays the littlest unit of issue that can't be partitioned utilizing compound methods. 10 interesting facts about atoms. 1. There are 3 sections to an atom. Protons have a positive electrical charge and are discovered together with neutrons, no electrical charge, in the core of every molecule. Adversely charged electrons orbit the core. 2. Molecules are the littlest particles that make up elements. Every component contains an alternate number of protons. For instance, all hydrogen particles have 1 proton while all carbon iotas have 6 protons. Some matter comprises of one kind of molecule, e.g., gold, while other matter is made of molecules fortified together to form compounds, e.g., sodium chloride. 3. Iotas are generally unfilled space. The core of an iota is incredibly thick and contains virtually all of the mass of every particle. Electrons contribute next to no mass to the iota. It takes 1,836 electrons to rise to the size of a proton, and circle so distant from the core that every particle is 99.9% void space. On the off chance that the iota was the size of a games field, the core would be the size of a pea. Albeit the core is a lot denser contrasted and the remainder of the particle, it also comprises essentially of void space. 4. There are more than 100 various types of iotas. Around 92 of them happen normally, while the rest are made in labs. The primary new particle made by man was technetium, which has 43 protons. New iotas can be made by adding more protons to a nuclear core. In any case, these new particles, components, are precarious and rot into more modest iotas momentarily. For the most part, we just realize another molecule was made by distinguishing the more modest iotas from this rot. 5. The parts of a molecule are held together by 3 powers. Protons and neutrons are held together by the solid and feeble atomic powers. Electrical fascination holds electrons and protons. While electrical aversion repulses protons from one another, the drawing in atomic power is a lot more grounded than electrical shock. The solid power that ties together protons and neutrons is multiple times more remarkable than gravity, however it acts over a short reach, so particles should be near one another to feel its impact. 6. Molecule comes from the Greek word for uncuttable, or unified. The name comes from the 5th century BCE Greek savant Democritus, who accepted matter comprised of particles that couldn't be cut into more modest particles. For quite a while, individuals accepted molecules were the major, uncuttable unit of issue. While molecules are the structure squares of components that can be isolated into still more modest particles. Also, nuclear fission and atomic rot can break particles into more modest iotas. 7. Iotas are exceptionally little. The normal molecule is around 1/10 of a billionth of a meter across. The biggest iota, cesium, is around multiple times greater than the littlest particle, helium. 8. Despite the fact that iotas are the littlest unit of a component, they comprise of much smaller particles called quarks and leptons. An electron is a lepton. Protons and neutrons comprise of 3 quarks each. 9. The most plentiful sort of particle known to mankind is the hydrogen iota. Almost 74% of the particles in the Milky Way system are hydrogen iotas. 10. You have around 7 billion iotas in your body, yet you supplant about 98% of them consistently.
If you enjoyed this video, be sure to give it a like and subscribe to Life is Often if you haven't already. Click the bell icon to stay updated on all our latest content.